Hey, this is for Danya, because you're the only one I think is going to be watching this video of mine because you're in the bridge program. So we are, for regular math 3, we finished with the graphing everything else notes. Well, in enhanced math 3, we would have done this and I think 1, 2, 3 more notes after, so 4 more after that. So this is the first one. So I'm going to give you all of them. I'm going to give you the homework assignments. So just please go through them. I mean, I'm not going to test you on this stuff, but definitely turn in your homework into the drive like I have for you for the bridge program. And turn in your stuff so I can see that you're doing the work. And yeah, okay. I'll try to post the homework answers as well. I'll probably put them in the same video for you, Danya. That way, I want you to be on your honor though. Like when the notes are finished, then go ahead and pause, do the homework, and then check. Okay, so try to do it all in one whack. So I know this will be a long time, but try to do it in one sitting. That'll probably be the best. That's what I recommend. And that way you can get it done. And you're just doing it because you need to do it for the bridge program, but you're not being graded on it. So there's really no pressure. So just have fun learning. Try to have fun learning. You're in the bridge program for a reason, and that's because of the major you have chosen. So just keep that in mind when things start getting a little hard or you have trouble understanding. And if you have trouble understanding, please make sure that you're reaching out to me. I haven't heard from you in a while, and I only saw that you turned in the first limits assignment. So I haven't heard from you since then. So just please, if there's anything you need, or if I didn't send out answers, which I might not have sent out answers for 11.2, 3, and 4. So I'll make sure to email that with you when I email these. But if I missed anything to send you, please let me know, Danya, okay? So, girl, this is all for you, sweetie. So yeah. Okay, so inverse trig functions. So we've talked about sine, cosine, tangent, cosecant, secant, cotangent. And now we're on inverse trig, and that's where we have, to the little -1 power there, okay? And so we're going to start with a warm-up, and this is what I would have started you guys with if you were in Enhanced Math 3 and if we were in class together, okay? In fact, I did teach this in Enhanced Math 3, and we were in class together still, so we made it through the whole unit before the pandemic happened. But anyways, it says graph f of x equals x squared plus 2. Identify if it is 1-to-1. That's something that we learned last semester. If not, restrict the domain so its inverse is also a function. Okay, so I'm going to use a couple colors here, and I hope that these are bright enough for you, and I'm going to zoom in. Okay, so f of x equals x squared plus 2. So this is a parabola because of the x squared, and it's the parent function shifted up 2 units. So the parent function always starts at 0, 0, so up 2 units puts me at 0, 2. It's a positive x squared, so I know it's facing up. And then remember, we use the basic parent function has up 1 over 1 from the vertex. When we also did the 1 over 4p thing, which you guys will be tested on the final. But yeah, okay. Which, by the way, final is optional. So if you're looking to get a percentage boost on your grade and you want a chance to do that, you could take the final. And if you pass it with a high enough score that boosts you, then I'll put it in your grade book. If it doesn't, then I'm not going to make it count against you, okay? All right, so here's our parabola. And we need to identify if it's 1-to-1 or not. So remember, to be 1-to-1, that means it has to pass 2 tests, the vertical line test and the horizontal line test. So obviously, if I have a vertical line passing through this graph, it's only going to pass through at 1 point at a time. So it passes the vertical line test. But if I have a horizontal line going through it, it's going to cross through in 2 spots. So it fails the horizontal line test. Okay, so I'm going to use the screen marker, and I'm going to draw a horizontal line. And then I'm going to say off to the side, fails the HZ, horizontal line test. Okay, so because it fails the horizontal line test, that means that this is not 1-to-1. and we have to restrict the domain. So remember, what happens is that when we do Freaky Friday, so we have y equals x squared plus 2, we switch the x and the y, and we get y, or x equals y squared plus 2, and then we solve for y. So what happens is we basically, let's Freaky Friday these points. So this is the point 0, 2. Freaky Friday the point 0, 2, you get 2, 0. Freaky Friday the point 1, 3, and you get 3, 1. Freaky Friday the point -1, 3, and you get 3, -1. So that's why it's not 1-to-1, because the inverse doesn't pass the vertical line test. It's not a function. To be a function, it has to pass the vertical line test. To be 1-to-1, it has to pass both tests. So we have to restrict the domain. We have to either chop off the, oh, sorry, I probably shouldn't use that finger. The bottom half or the top half, because if we chop off one side or the other, it'll be 1-to-1, okay? So we have to restrict that domain. We always usually pick the positive side to chop off, so I'm gonna, basically pretend that bottom part is not there. So the domain, and I'll use the inequality notation, is x, we're at the 2 there, x has to be greater than or equal to, and we're looking at this function that we have to restrict. So x has to be, that means I'm also chopping off half of this, right? Because that means only this part is getting reflected. So that means that x can't be passed, or x has to be past 0, right? Because we're chopping off the negative side. So x has to be greater than or equal to 0. And so that's one way we could restrict the domain. Or if I decide to chop off the positive side instead, that means x has to be numbers that are negative, so less than or equal to 0. So, or x less than or equal to 0. It has to be one or the other, not both. And when you're restricting the domain, you're always restricting the domain of the original, not the inverse. Okay? All right. So that's what we learned last semester. So how do we apply that to the here and now? Okay, so now, well, we're doing trig, and we just dealt with graphs of sine, cosine, tangent, cotangent, secant, cosecant. And it says, looking at the basic sine and cosine waves, okay, so I'm gonna zoom in on that first one. There's the sine of x, okay, and we know that it's going to pass the vertical line test, okay? So it is a function. It's a trig function. But if I were to draw a line through these humps, that tells me that it fails. It's going to cross 1, 2, 3, 4. It's going to cross an infinite number of times through the sine wave because the sine wave is continuous. So it blatantly fails the horizontal line test. Okay? So it's not 1-to-1, which means that we have to restrict the domain. So we're going to restrict it here. Okay? So what we have to do is we have to find a piece of the graph that is 1-to-1. So in order to do that, what we do is we're going to restrict a cycle out of this. So if I basically need to chop it off so that it doesn't go through another hump anywhere. So I can only have one little curve in there. So what I can do is, well, I have this point up here where it starts before it starts coming back down, and I have this point down here before it starts coming back up. Okay, so I can restrict it from here to here. Now those aren't labeled there, but if you see, they're labeled by pi's, but there's dash marks in between. Well, halfway between 0 and pi would be half of pi, or pi over 2. So this would be pi over 2, and this would be negative pi over 2. So if I restrict the domain to negative pi over 2 and positive pi over 2, that would be the restriction that I need so that the sine wave is 1-to-1. Okay, I'm going to highlight that because I feel like it makes the notes pop out more, and it's just, I don't know, fun. Keeps it interesting. Gives you something to do. All right, so here's the cosine wave, and we have to kind of do the same thing. because obviously this is not going to pass the the horizontal line test. So again, it fails. Failure is part of life. We got to learn from our mistakes, so it's okay to fail sometimes. We'll fix it. So we need a interval that will do the job for us. And I'm seeing that I can hit the top of this hump, so I can have like an asymptote there, and then the bottom of this hump. I have to go from a hump to hump. And the gump of Wumper, I don't know, makes me think of a Dr. Seuss book or something. Okay, so from here, this would be 0, because that's on the y-axis, 0 to pi. So that's what I'm going to restrict it to. 0 less than or equal to x, less than or equal to pi. And that will be the restriction that we need to place on the cosine wave so that its function is 1 to 1. So that its inverse is also a function. Okay, so what do we know? We know that neither graph will pass the what test again? If you're paying attention, it is the horizontal line test. Neither one of these graphs pass the horizontal line test. My kids are watching Pocahontas in the background, by the way. So we have to restrict them, which is why we wrote the restrictions on the domain. We have to restrict them, okay? And there are restrictions, so the zeros are pointing to them, okay? So when we're looking at the graph, what this lesson does, it kind of helps you narrow some things down when you're answering questions about the sine, cosine, tangent, whatever on the unit circle. It makes answering those questions a lot easier, okay? So I'm going to start with the sine of x. I'm going to use a yellow highlighter. Sine inverse of x. So because the sine has to be restricted from negative pi over 2 to pi over 2, that's going to help me figure out where on the unit circle sine inverse of x will be located. Okay, so let me zoom in. So we know that positive pi over 2 on the unit circle is up here. And if I go clockwise, negative pi over 2 on the unit circle is down there. Okay? So if we have to restrict the domain to be between negative pi over 2 and positive pi over 2, that's just this right half of the unit circle. So I'm going to take my highlighter again. And so that means that the sine inverse will only be located in those two quadrants, quadrant 1 and quadrant 4. Okay? So we basically use this when we are looking for an angle. We're like, where would it be? Now, sine of an angle, oops, I spelled angle wrong, is in all 4 quadrants. But when we're trying to find its inverse of any sine, that angle is going to be narrowed down to these 2 quadrants. Okay? All right. And it's got to be one or the other, because the sine would be positive up here and negative down here. Okay. Now for cosine, I'll use a different highlighter. Where's my pink? Oh, here it is. My son borrowed it earlier today. Okay, so cosine. Okay. Now the cosine restriction is from 0 to pi. So on the graph here, I'm going to mark, this is 0 radians, and then this is pi radians. So from 0 to pi, that means that the cosine inverse would be located in the first quadrant or the second quadrant. And it can't be both, because cosine in the second quadrant is negative and cosine in the first quadrant is positive. So from here on out now, there's only one answer. So you know how sometimes it was multiple possibilities? Now we can narrow it down. Only one answer from now on. Okay? All right, so when we're answering questions about this, we can remember when we're looking for sine inverse, it won't ever be in the second or third quadrant. When we're looking for cosine inverse, it won't ever be in the third or fourth quadrant. So that really does help us narrow some things down, and it's kind of nice, okay? So here are our first examples. We're going to find the exact value of theta, and we're going to stick with radians. Where is, oh, there's my green one. Radians only. So we're going to keep it in radians. Okay. So the sine of theta equals -1/2 versus the sine inverse of -1/2 versus the arc sine of -1/2. What's cool about all of these is that they are all the same question. Well, how can that be? They look so different. Well, they're very, very similar, okay? So we're looking at where on the, I like to switch colors, where on the right side of the circle is the y value, -1/2. Okay, so when the sine is -1/2, not sine inverse, just sine, on our unit circle, I wish I had one out in front of me, so give me just a second, let me pull it out. And you can fast forward this part if I'm taking too long. Where's my unit circle? I must have taken it out. Okay, well, I'm going to take out my notes because I have them written down in multiple spots. So, sine is -1/2. So sine is positive, positive, negative, negative down here. So sine could be 7 pi over 6. That could be the angle. Or 11 pi over 6. Okay? But sine inverse is only in these two quadrants. So that means we're looking at 11 pi over 6. But because it can only go from negative pi over 2 to positive pi over 2, that means that 11 pi over 6 going clockwise is the same as pi over 6, negative pi over 6. Okay. Sine inverse of -1/2, well, since these are all the same question, these are asking the same thing. And so is this one, the arc sine of -1/2. So, negative pi over 6 is the angle. So just remember, since I'm going from here to here, negative pi over 2 to positive pi over 2, like these ones are the positive radians, but down here are the negative radians because we're going clockwise. Okay, and then from here to here, we have no chance to hit this side, so these are only going to be the positive radians. Okay, all right. So now that we are restricted, we only get one answer. Okay, all right, on to the next page. We have some more examples. So as you see the examples, these are going to make a lot more sense as we go. In case, because I don't know, sometimes I feel like I sound confusing, but I do the best that I can to explain. And if it was confusing in class, you guys would tell me and be like, Miss Garcia, can you say that again? Or can you give me a different example? And then I'd be able to explain it better. But I don't have you guys to tell me that right now, so we just got to wing it. Okay, so we need to decide if it's on or off. And when we're talking about that, we're talking about on or off the circle. Okay, so let's take a look at number 4. And where did I put my highlighter? I'm going to highlight number 4 in yellow for a reason. Okay. Cosine inverse of square root of 3 over 2. Square root of 3 over 2 should look very familiar because it is on our unit circle. Okay. And cosine inverse is what we're trying to find. And if we remember from the previous page, cosine inverse is only in the first and second quadrant. So what I like to do to remind myself that is to draw a quick little pic of the unit circle and know that cosine inverse is only in those first two quadrants, okay? And cosine is positive square root of 3 over 2, right? So that would be not here because that would be a negative angle. It's got to be over here, where the cosine is the square root of 3 over 2, the sine is 1/2. and that is pi over 6. So I want to write this out, and you don't have to write this out when you're doing the homework part, but for your notes, the question is, where on the top half is the x value square root of 3 over 2? That's what we're really asking ourselves. Where on the top half of the graph is the x value, a positive square root of 3 over 2? Well, it was only in the first quadrant, and there's only one angle in the first quadrant that has an x value of square root of 3 over 2, and that is at pi over 6. Okay. Number 5, the sign of x equals 1. Well, 1 is a number that is on the unit circle because the radius is 1 unit. So this is still an on question. And so we have to ask ourselves, where on the unit circle is the sign a 1? Well, we know that sign has to be restricted because we need its inverse to be 1 to 1. So remember what we learned on the first page. Sign is only on the right side of the graph. So again, I like to draw a little picture to remind myself of that sign is not in these two, it's in the right side, on the first and the fourth quadrant, okay? All right, so sign is a positive 1, remember up here, that's the point 0, 1, okay? And what angle is that? Well, that is pi over 2. So this equals pi over 2. Okay. Number 6, arc cosine. Remember on the previous page, arc cosine, arc sine, that just means the little -1. Sometimes you'll see it interchanged like that, especially in college. A lot of the old math textbooks use arc sine for the inverse, or arc cosine, whatever. Okay, so we're finding the inverse cosine, and again, we know that cosine, remember from the last page, is in the top half of the graph. So the bottom half is going to remain untouched, and where on the top half is the cosine? A -1/2. Well, -1/2, cosine's negative on the second quadrant, not in the first. Both cosine and sine are positive in the first, but cosine is negative in the second, sine is positive in the first. So the cosine is a -1/2. So it wouldn't be that one. It's got to be this one. And then that means that the y, the sine, would be the square root of 3 over 2. So we know it goes pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3. So the angle that makes this true is 2 pi over 3. Okay, and that's just by knowing your unit circle, okay? So if you don't know it, because I didn't really require you guys to really memorize it like I did with my Enhanced 3, because you can always look back at it for right now, but like when you get into calculus, you're gonna need to have a really good grasp of this, especially when we're dealing with calculus involving the sine, cosine, and tangent waves, okay? All right, so I recommend, maybe over summer, just practice drawing it here and there. Be like, do I remember the unit circle? Let me draw it out, and try to draw it out from memory and see, and keep practicing that over summer. And sometimes we do have to do those things. Oh, I forgot to mark 6 was a on circle problem. Okay. Number 7, obviously, is not an on circle problem because I have -0.4321. And there's no decimals on our unit circle, not like that. So this is an off problem, and I'm going to highlight them in pink. That way we can color code them and know which one's which, especially when you go back to look at your notes when you're doing the homework and stuff. So we have the arc sine of -0.4321, and we have to remember something extremely important because we're going to have to use our calculator, and we have to remember what? You remember what was on the last page? Radians only, no degrees. So that means our calculator has to be in radians, so we have to remember to switch the mode, okay, which is so easy to forget. Even I do it, but we just got to be careful about that and diligent. So my calculator, I'm going to go ahead and change the mode to radians. If you're using, I think you had one like this. I think yours was blue, if I remember correctly. See, this one's in degrees still, so I have to change it to radians. So I just hit the DRG button, and then I scrolled over and hit radians. So it just depends on which calculator you have. I like using this one because, I mean, you still type it the same way as in the other one, but I like being able to see everything on the screen, and that's what's nice. By the way, Danya, you're gonna need to get one of these, and you can find them for a lot cheaper than full price on eBay if you guys have like a PayPal account. That's what I recommend, because otherwise you're looking at like $100, $120, and you definitely want to get a TI-84. Like this one is the one that Mrs. Ardito recommended, because the TI-89, even though it's newer, is really, really hard to navigate. And in fact, I bought one on eBay and I have no idea how to use it, and it was so frustrating. I wanted to chuck the thing across the room. I tried to get John Valenzuela to help me, but he didn't know how to use it either. And so, yeah, the struggle is real. So get one of these. All right. Oh, and by the way, to get the standard black or navy blue ones, it's way cheaper than getting a colored one. Like, I really wanted the pink one, so I went for that on eBay, but it was still cheaper than paying full price. But just want to throw that out there. It doesn't have to be a cool color. It can just be a generic color. I just got a little picky. All right, so when we type this into our calculator, this is what you're really typing in. You're typing in the sine inverse, because that's what arc sine is, of negative 0.4321. So we're going to type that into the calculator. So second sine of negative 0.4321. And I get negative 0.4468. Did not say how to round it, but I think I want to go out 4 decimal places since the number we plugged in was 4 decimal places out. So I'll put negative 0.4468. So this is approximately negative 0.4468. And that's the answer. So when it gets to the calculator ones, those are even easier than these ones, because you don't have to remember the unit circle or nothing. You just have to type it into your calculator, which means you just have to know how to type it into your calculator. All right, number 8 is obviously also off the circle, because 0.28 is not a number you'll find on the unit circle. So literally, this is what we're going to type into the calculator: cosine inverse of 0.28. So second cosine of 0.28, or you could type in 0.28, it doesn't matter, you don't need the 0. And I get 1.2870, so I'm going to put 1.287. 1.287. Okay? All right, here are the next set of examples, and they are on evaluating. I like this song. Okay, so here are the instructions. When we are evaluating, we have to think of like order of operations. We are always going to start inside out, start with the inner parentheses and work your way out. Like you're dropping a stone in a lake and it ripples out, so you start from the inside and work your way out. We also have to remember the restrictions on the inverses, because that helps us narrow down where it's going to be on the unit circle. Okay? All right, so number 9, we have the sine of the arc cosine of 1/2. So first of all, we need to start here. Start with the arc cosine of 1/2. So where on the circle is the x value a positive 1/2? And remember, cosine is only in the top half of the graph. Remember the notes we took on the first page? So cosine is not positive in the second quadrant, so that means it's not going to be in there. So it's got to be over here. And cosine is a positive 1/2, not right there, it's the third one up here. Cosine is a positive 1/2 when the sine is square root of 3 over 2. That is the, because it goes pi over 6, pi over 4, pi over 3. So that's the pi over 3 angle, okay? So I can rewrite that. Arc cosine of 1/2 is pi over 3. So now I can replace the arc cosine part with just pi over 3. So now I'm trying to find pi over 3. So now I'm working on this. Okay, where on the unit circle is the sine of pi over 3? Okay, well, now I've got to look at the sine graph Okay. And pi over 3, so it goes pi over 6, pi over 3 is up here. Oh, I could have just used this one. It's right there. The sign is the y value on pi over 3, which is square root of 3 over 2. So that's the answer. I didn't even need this graph. I don't even know why I wrote it. Okay. So that process of elimination really does help bring down the possibilities of your answer, and you truly only get one answer. Okay, so number 10, got to work on the inner parentheses. We're trying to find the sine inverse of negative square root of 3 over 2. So where on the unit circle is the sign a negative square root of 3 over 2? Well, remember from the first page of notes that sine is only in the first quadrant and the fourth quadrant here, sine inverse. Okay, so where's sine negative? Well, it's not in the first quadrant, it would be down here. So sine is negative at this angle because that is where the cosine is square root of 3 over 2 and the sine is negative 1/2. Okay, so that would be, remember it goes from positive pi over 2 to negative pi over 2, so this would be a negative pi over 6, negative pi over 4, and then that third mark would be negative pi over 3. Okay, so this changes to the cosine of, now that I know that sine inverse of negative square root of 3 over 2 is negative pi over 3, now it turns into cosine of negative pi over 3. Okay, and what is the cosine of negative pi over 3? Well, the cosine is the x value right there, which I already have on my graph. So the answer is the negative pi over 3. I think on my notes I put the wrong one, but it should be square root of 3 over 2. Okay, I think on my notes I have 1/2, but that's incorrect. Yeah, what x value at negative pi over 3? I think I put it in as pi over 6, not negative pi over 3. But yeah, this one's correct. Okay, so number 11, the sine of the arc cosine of 2/5. Okay, well, this is not on the unit circle, so this is an off circle problem. And I have to take that 2/5 and I have to drop it as a reference triangle. Okay, so we have to make this reference triangle on the graph. So cosine of 2 over 5, so cosine is adjacent over hypotenuse, and both of these are positive, so the cosine is positive. Oh, and also cosine would be the top half of the graph, right? Okay. So the cosine is positive on the top half of the graph in the first quadrant, which would be over here. So here's my reference triangle, and here's theta. Cosine of 2/5, so adjacent side is 2, the hypotenuse is 5, the Ka of SOHCAHTOA. And I need to find that vertical side right there, so I'm going to have to use good old Pythagorean theorem. So a squared plus b squared equals c squared, so I'll call this side b, and I'll have 2 squared plus b squared equals 5 squared. 2 squared is 4. 5 squared is 25. Subtract 4 from both sides, b squared equals 21. Square root both sides, and b just equals the square root of 21 because you can't reduce that anymore. So this is the square root of 21. Okay, all right, so I have that going on, and now since I know that it's a reference triangle, I need to find the sine of theta. Okay, so now because sine is outside the parentheses, so now I'm going to use this information to find the sine of theta. Okay, sine is the SO of SOHCAHTOA, which is opposite over hypotenuse, so that would be square root of 21 over 5. So you're basically using one part to get to the next part pretty much. Okay, so here's the homework portion. So go ahead and press pause and get out a piece of paper and try these out, see how you do. Attempt them all before you and please try not to skip any of them. Give each one a shot and then watch me go through them on the homework. So go ahead and press pause. Okay, so hopefully you hit pause. If you didn't, I mean, I don't know, so there won't be any judgment because I don't know, and I would try not to judge anyway because, you know, it's me. But anyways, I'm hoping that you didn't just keep going, that you paused it. But all right, so number 1, we are trying to find the cosine inverse of square root of 2 over 2. Okay, so remember, where is cosine located? Cosine is in the top half of the graph, so the bottom half is x'd out. And cosine is positive square root of 2 over 2, so that means that we're in the first quadrant. So I can x out that second quadrant. So I'm in here, and only one angle has a cosine of positive square root of 2 over 2, and that's the 45-degree angle one right there. The square root of 2 over 2 for x, and the square root of 2 over 2 for y, because it's an isosceles right triangle. So this would just be pi over 4. Kids, I need you to settle down. Number 2, we have the sine inverse of -1/2. So let's recall where sine would be located. Well, sine would not be on the left half, it would be on the right half of the graph. Okay, and sine is -1/2, and negative sine is in that fourth quadrant. All right, get out. You need to go to your room then. If you're not going to be quiet, go to your room, please. Sorry about that. Okay, so we're in that fourth quadrant, and sine is -1/2, so that means that the cosine must be square root of 3 over 2. So that's this angle right here. Square root of 3 over 2, sine is -1/2. So that's the, so it's a pi over 6, but it's going in the negative direction, so it's a negative pi over 6. So this equals negative pi over 6. Okay. Arc sine of the square root of 3 over 2, so it's basically sine inverse, okay? Sine inverse is square root of 3 over 2. Well, we know that sine is only in the right half of the graph, and this sine value is positive, so it's in the top half, not the bottom, okay? So we're in the first quadrant, and the y value is the square root of 3 over 2 way up here. That's where the x value is 1/2, and the y is square root of 3 over 2. Okay, and that angle right there, it goes pi over 6, pi over 4 is pi over 3. So this one is pi over 3. Violet, can you turn this down a little bit? Okay, number 4, sine inverse of 0.841. Oh, that's not on my unit circle, so I'm going to go ahead and use my calculator. So second sine of 0.841. And it doesn't say how to round it, but since the number we plugged in is out to 3, let's round out to 3. So 0.999. 99999. So approximately 0.999. Okay. Number 5, arc cosine of 0.4726. Okay, that is not on my unit circle, so I get to use the calculator again. So that would be second cosine of 0.4726. Yeah. And that is 1.0786 if we go out 4 decimal places. 1.0786. Put that stool back, Lucas, now. I have told you not to do that with my footstool. No, she did not. You did. Oh, it's always Sissy's fault, but he's the one that always does it. Okay. Oh, I didn't box it. Number 6, sine inverse of 3/8. Okay. Because it's a fraction, not a decimal, we can drop a reference angle to it. Or we don't have to. We could just type in 3/8 in our calculator. Yeah, we could just do that. So we're going to have second sine for sine inverse of 3 divided by 8.